All right, my pre-calc babies. We are back for another lecture, chapter 9, section 1. So, do you feel like this, at this point in time in your pre-calc 2 course on the trigonometry, do you feel like you're kind of sick of triangles, maybe? Maybe you've just had your fair share of them? Well, the good news is we are going to move into the topic of what we call conic sections. And the first conic section that we're going to discuss is the idea of the ellipse. So I'm presenting to you just right now two different types of ellipses, a horizontal and a vertical ellipse. And you can imagine, now, of course, a circle is just a special type of an ellipse, but you can imagine that if you were to grab a circle and stretch it either horizontally or stretch it vertically, you can see the outcome, right? The shape that you're looking at right now. Now, what I want to do is I want to start with, I'm going to define what we mean by an ellipse, and then we're going to go into, I want to share, there's some really interesting applications with the study of the ellipse, but I'll share one of those applications with you really quickly, but then I want to discover some vocabulary that I'm going to be using throughout this lesson to make sure that you are on par. Ready? So the definition of an ellipse is the set of all points in a plane. Okay. Now this next part will make more sense on the next page. So the set of all points in a plane, the sum of whose distance from 2 points is the same. All right. So we'll make sense of that statement in just a second. So if you have you ever heard of a whisper room? Now, there's a few museums, at least local. I believe there's one in Richmond, Virginia. But there's they have an exhibit, a special semi-elliptical room, look something like what I've tried to draw here. And inside the room, they have, marked off two different points, right? And what you can do is you can just say you have two individuals who enter the room, and they stand at these points that are marked off, right? And one of the interesting things about an ellipse is that those two points, those what we call focal points, have a property that any wave, any say sound waves that are emitted from one of these focal points will bounce off the semi-elliptical walls and go directly to the other focal point. Now, why is that interesting? Well, that's interesting is because what you can do in these whisper rooms is you will be a fairly large distance from each other. Far enough to where normally if you were whispering that you would never be able to pick up the audio, right? You'd never be able to pick up the sound waves. But when these two individuals are standing on these two focal points, they can whisper just like you would whisper normally, and it will almost seem like this other individual is right in front of them, right? They're right there beside them. Now, if you take a step to the right or left or back or forth, if you off of those focal points, the whispers will no longer be audible. But from those 2 points, you could carry on a conversation just whispering. All right. So the set of all points in a plane, the sum of whose distance from 2 points is the same. What do we mean by that? What the distance from 2 points is the same. So these 2 points, just like in the previous example where you were, the places that you were standing in this whisper room, these 2 points are what we call the focal points, right? And what's interesting is although the focal points are not on the ellipse, right? For example, point P is on the ellipse, but the focal points are not on the ellipse, but the focal points is what are needed to define the ellipse. So when they say in that definition, the set of all points, the sum of whose distance between 2 points is the same, what they mean by that is, look, now point P, this point in the red, that point is for sure, that's on the ellipse. Now, the distance right? The distance from point P to the first focal point, we'll label that D sub 1. And then there's a distance from point P to the second focal point, which we'll label D sub 2. But so as you travel around this ellipse, I think you'll agree with me, D sub 1 and D sub 2 are constantly changing, right? Like the distances are going to be different depending on where you are in the ellipse. But what that definition says is the sum of the distances is always the same. Okay? All right, now let's go ahead and try to go through some basic vocabulary. I don't like spending a lot of time on vocabulary, but this is a new topic, and we need to have there's a certain language that we need to be able to use in order to convey ideas back and forth. And so, but let's start with the idea that point P, right, is for our purposes, this is just some point, some arbitrary point on the ellipse. All right. Now, the focal points, okay, we're going to, in this case, we've labeled them C and negative C. The focal points are the points that are used to define the ellipse. All right. Now, the center of any ellipse. Now, this one is centered at the origin. That is the easiest type of ellipse to deal with. But as you can imagine, there's no special reason that the ellipse must be centered at the origin. We can translate that graph to another location, but the center of the ellipse is always the midpoint. Right? The midpoint between the two between the foci, right? The midpoint. I think I'll say between, and we'll write it as, this is going to be a line segment, C and negative C, but it's the midpoint of that line segment. Of focal point. Right, so in other words, if you think about this line segment here, the midpoint, that is the line that connects focal point to focal point. And the center of the ellipse is always in the middle of that, right? It's the midpoint between the two focal points. Okay. So now there's, I'm going to erase that. There's two different axes that we refer to often. Okay, and one is the major axis of the ellipse, and one is the minor axis of the ellipse. So let me start with the major axis. So what we mean is the major axis is the distance, I'll write it in just a second, but it's the distance from one side of the ellipse to the other side of the ellipse, going through the focal points in the origin, or I should say through the focal points in the center, right? Now, we give these a name. These are called vertices of the ellipse. But since I haven't got to that yet, I'm just saying it is the major axis is the distance. This is the key word. The distance from negative A to A through focal points. Okay, does that make sense? Does it make sense to you that the focal points are always on the major axis? Okay, that's where the focal points lie. Now, it should make sense to you that the length of that major axis, well, it's if you were standing there at the center, at the origin, and you travel A to the right, or you can travel negative A to the left, the distance from negative A to A is 2A. So the length of the major axis is 2A. Okay. Now what about the minor axis? So the minor axis is going to be the distance. Now, if I recall correctly, I think that your book refers to both of these as just, they refer to A, negative A, B, negative B. They refer to all of those as vertices. But when I was, long ago, when I was in college, we would refer to these guys right here, B and negative B, would be co-vertices, whereas A and negative A would be vertices. But the minor axis is simply the distance or the length from B to negative B, or I'll say from negative B to B, again, but this time through the center. Not through the focal points, right? The focal points are not on the minor axis. They are only on the major axis. Now, the length of that, if you start at negative B and then you travel all the way to positive B, you would have gone a total distance of 2B. All right, major axis, minor axis. And finally, the vertices. Okay, so I'll just go ahead and write that as, so we'll say vertices A and negative A on major axis, and vertices B and negative B, which I call co-vertices, on the minor axis. All right, so we're going to start with two different equations of the ellipse. Now we're going to start with the easiest case, where we let the ellipse be centered at the origin. Right? It's kind of like a if you recall, when you're dealing with circles, the equation of a circle that's centered at the origin was just the x squared plus the y squared equals the radius squared, right? Same idea. Only it's just much easier if it's centered at the origin. Otherwise, you'll have to deal with the HK definition of the equation of the circle. Same thing with the ellipse. So I'll go ahead and write center 0, 0. All right. So we have two different equations, right? So we have x squared over a squared plus y squared over b squared equals 1. And then we have x squared over b squared plus y squared over a squared equals 1. Now, how do you know which one is the vertical, which one is the horizontal? Well, let me go ahead and try to address that question right now. So a squared, okay? If you look at both formulas, a squared is in both formulas. Probably the best way that I can explain this to you is that if you stretch your circle, remember if you start with a circle and you stretch it more in the horizontal distance, then that would mean a squared is larger under the x squared because you stretched it horizontally, right? If you would have took the same circle but now stretched it vertically, you would expect to find that the larger denominator is under the y squared. Does that make sense? So maybe I can try to capture it this way. What I'm going to do right now is circle the larger denominator is under the x squared when you have a horizontal ellipse. The larger denominator is under the y squared when you have a vertical ellipse. This will all make sense when we do a problem. The last thing that you're going to need is the relationship between all of this information, right? So does it make sense that you have a and negative a, those are vertices, you have b and negative b, those are vertices, then you have c and negative c, which are focal points. Well, the relationship between your focal points and your vertices are b squared plus c squared is equal to a squared. All right, now you can always pause this and or click back and refer back to it, but we're going to go ahead and jump in and try some problems. So what are we asked to do? Well, we're asked to graph the following ellipse as well as locate the focal points, right? So when everything is said and done, we should have the graph of what this ellipse looks like, and we should be able to find the focal points, where the focal points are. All right, let's see if you are listening to me. So notice I have a denominator of 9 under the x squared, and I have a denominator of 4, right, that's under the y squared. So my question, the first question that you should ask yourself is, are we dealing with a horizontal or a vertical ellipse? Right? All right, well, hopefully you were listening to me when I said that if the larger denominator, look, 9 is larger than 4. Since 9 is under the x, this means that this is going to be what? This is going to be a horizontal ellipse. Okay, if the 9 was under the y, this would be a vertical ellipse. All right, so let me go ahead and write, this is the equation, right? X squared over a squared plus y squared over b squared is equal to 1, right? This is the equation for a horizontal ellipse that's centered at the origin. And this is centered at the origin. All right. So what are you going to need to do to graph, right? We're going to need to graph the ellipse. Okay, well, let's start. What we know that a squared is equal to 9. Right? My apologies, my a's are starting to look like This is a squared is equal to 9. And we also know that b squared is equal to 4. All right, that's great. But we need to know what is not a squared or b squared. We need to know what is a, what is b. So that would mean a is equal to the plus or minus the square root of 9. And again, b is equal to plus or minus the square root of 4. All right, so that would mean that a is equal to plus or minus 3, and that b is equal to plus or minus 2. Ready? So let's go to, let's pretend like we start at the center, the origin, and now you are going to travel, since look, the 9 is under the x, right? So you're going to travel 3 units to the right and 3 units to the left. So 1, 2, 3. So this is a is equal to 3. And then 3 to the left. So here's where a is equal to negative 3. All right, now likewise, you're back at the center. You're now going to travel 2 up and 2 down. So that would put me here. This would mean b is equal to 2. That would put me here. B is equal to negative 2. Now, I could try to draw this ellipse. You'll laugh at me. It looks like that's good enough. So that would be the graph of that ellipse. But we still haven't answered the question as to what are the focal points, right? Foci, the plural, the focal points. Well, obviously there should be 2 focal points, correct? That's what we're looking for right now. And now let's see if you have command over your vocabulary. So let me phrase it this way. Are the focal points going to lie on the x-axis or the y-axis? I don't care if somebody's around you. Answer the question. Just answer it out loud. Right? Okay, good. It is. It's going to lie somewhere on the x-axis, right? Because the focal points are always on the major axis. And in this case, the major axis, which runs from a to negative a, through the origin, through the focal point. So we need to find where those focal points are. Ready? All right, so notice that we really didn't need much except the equation to get everything graphed out. But to find the focal points, I'm going to kind of go back a slide. We're going to need this relationship, b squared plus c squared, copy, is equal to a squared. All right, so we're going to need that relationship to answer this question. All right, so what we're going to do right now is we're going to just plug everything in. So we have b squared was equal to 4 plus c squared. Well, that is going to be where our focal points are. We don't have that yet. And that's got to be equal to a squared, which is 9. With me? So c squared is equal to 5. That means c is equal to plus or minus the square root of 5. Okay, so let's get back up here. You start again at the center of your ellipse. You're going to travel the square root of 5 to the right, and you're going to travel the square root of 5 to the left, right? So the square root of 5 is a little bit bigger than 2. So let's say right here. Let's say right here. So this is c, and this is negative c. All right, those are your focal points. Now, what do you think the most common mistake is? Because I don't think you will argue with me that this is remotely hard, right? In the sense that it's just basic arithmetic. But the hardest, or let's say one of the most common mistakes, is that students either they don't give me they either leave it like this, which is nice, but you didn't give me a point, right? Or when they plug the points in, they make the mistake of, well, putting the zeros in the wrong spots. So in this case, let's think about it. The y value is obviously 0. It is the focal points are going to be at the square root of 5 and negative square roots of 5. Right, so okay, so not bad. Not bad. So square root of 5 and negative square root of 5, you have answered the question. You have given me the graph as well as the location of the focal points. So let me see if I can anticipate your question. So I would be thinking, hey, it's not that bad. How does it get harder? Well, really it doesn't. That's the good news. I'll give you a few of my tricks, but it really doesn't get much harder than the work that we just did. So you should, even if you did not excel in the trigonometry portion of it, you might excel in the conic section portion of this course. All right, so it says graph and locate the focal points. Looks just like the previous example, but that equation does not look like the previous example, does it? Right? That doesn't look like an ellipse. So how do we get around this? Well, all you're going to need to do is, remember, an ellipse is always equal to 1. So we're just going to divide everything by 400. See, this is one of my tricks. I give you an equation, and you can't even tell that it's an ellipse until you recall to divide everything by 400, because an ellipse is always equal to 1. And what do we have at that point? We have x squared over 16 plus y squared over 25 is equal to 1. Now, if you wanted to, you could pause the video and try it on your own, see how you do. I'm going to assume that you already did that, and I'm going to go ahead and get started. So let's agree the larger denominator is under the y. All right, this is telling. This is a vertical. This is a vertical ellipse. All right, now I'm going to go ahead and write the standard vertical ellipse. There's the standard formula where there's a squared and b squared. All right, so that would be x squared over b squared plus y squared over a squared is equal to 1. Okay, so that's the standard formula for a vertical ellipse. And now we need to proceed to figure out how to graph it. So all right, so in this case we have a squared is equal to 25 and b squared is equal to 16. All right, so that would mean a is equal to plus or minus 5 and b is equal to plus or minus 4. All right, square root of both sides. All right, let's go ahead and draw that out. So let's start at the origin. I'm going to be traveling 5 units up, 5 units down to get to the vertices. All right, so this is negative a, this is positive a. Right, because remember, A is always on the major axis. In this case, this is a vertical ellipse. All right, now I want to go back to the origin, the center, and I want to go 4 to the right, 4 to the left. So this is B, this is negative B. And now, now I have my co-vertices or my vertices. All right, so at that point, with just those 4 points, you can get a decent graph of the ellipse. right? Well, you could. I can't, right? I can't draw very well. But so we see what the general structure of this vertical ellipse is, but we still haven't answered the question as to what are the focal points. All right, now, I'm just trying to minimize mistakes, right? Focal points are points. You should be giving me a location, an X, a Y. Now, in this case, if you are absolutely correct that I am going to have to, I'm going to see if I still have this saved. Ready? Oh, I do. Good. Perfect. So it is true I'm going to use this little equation that relates the vertices and the focal points to help me out. But in the meantime, let me pose the question to you: Are my focal points going to be on the x-axis or the y-axis? Right. Yeah, they are. They're going to be on the y-axis. Okay, because notice that the focal points are always on the major axis. The major axis is always running from negative a to a. So I don't need to do anything. I already know the x values are 0 because I know that the focal points are going to lie on the y-axis. I just need to figure out how far do I go up and how far do I go down. Let's go ahead and plug in. So since b squared is equal to 16, so I have 16 plus c squared is equal to 25. This means that c squared is equal to 9. This means c is equal to plus or minus 3. Okay, so I would be going I would be going up 3, and I would be going down 3, and here is my focal points. All right, please don't be sloppy. Don't be sloppy. Write the focal points as points, right? Put the 3 here, put the negative 3 here. Let's take pride in our work, and we're done. Now, there's really only two flavors, right? Two types of questions that I'm going to ask. Are you listening? So either I give you the equation and ask you to find the focal points or the vertices or ask you to graph it, right? So either I give you the equation and ask information, or I give you some information and ask you to find the equation. That's the two varieties of questions. Okay? So we're asked to find the equation of the ellipse given the following focal points and the following vertices. All right, now listen to me. This is the key part right here. What you want to ask yourself is, where are my focal points located? Right? Okay, because you know they're always on the major axis. In this case, what? In this case, they're on the x-axis, right? Over one to the right, one to the left. So, in other words, this information right here is how you determine if it's going to be horizontal or vertical. Right? Just knowing the location of the focal points is what's going to help you here. All right, so let me go ahead and see if I can figure out. I'm going to go ahead and write the equation for a horizontal ellipse. So the equation is x squared over a squared plus y squared over b squared is equal to 1. All right. Now, look at the vertices that you were given in this problem. Let's try to figure out if those vertices are on the major axis or on the minor axis. So think about it for a second. Now, if you have to, you can always just do a quick sketch, right? It doesn't have to be pretty. Let me sketch the focal points. To the left one, to the right one. So that's my focal points. And now they give me two other vertices. I don't know yet if they're on the major axis or the minor axis. So let me graph those. If I go to the left 2 and I go to the right 2, well, look, those vertices are on the same axis that my focal points are on, right? So these are definitely on the major axis. That means if they're on the major axis, that this is the A and this is the negative A. All right, now we're getting somewhere. So let's you and I agree that in this case, let's start with focal points. C is equal to 1, right? So if I start at the center, I go 1 to the right, 1 to the left. So C is equal to 1. Therefore, C squared is also equal to 1. Okay, now let me use these other two vertices. So since the other vertices are on the same axis as the focal points, that would mean that is A. So in this case, A is equal to 2. Right? I gotta go 2 to the right, 2 to the left. That would mean that A squared is equal to 4. All right, beautiful. I already know what to plug in right here. What I don't know is what to plug in for B squared. Well, hopefully you guessed it. B squared. Let's see if I probably still have that saved. So let's see if I do. Beautiful. So here's my relationship between the vertices and the focal points. Let's go ahead and start plugging it. So I know what B squared is. I know what C squared is. And I know what A squared is. I don't know what B squared is. I know what C squared is. I know what A squared is. So that means B squared is equal to 3. All right, are you ready? Hold on for 1 second. I'm going to make a mistake. I want to see if you can catch it. Okay, don't write this because this is going to disappear. So here's let's assume I already know it's x squared over 4 plus y squared over, I'm about to write here something there in just a second. So let's assume b is equal to the square root of 3, and I write the square root of 3 here. Wait a minute. There's a problem. That's why I wrote it in red. What's the problem? What went wrong? Well, here's what happened. We, for sure, algebraically we have done nothing, or structurally we've done nothing wrong. I mean, if b squared is equal to 3, then b is equal to plus or minus the square root of 3. Maybe you're thinking I should have put a plus or minus in that result. Well, let's take a look at what we want. We want b squared. Don't you see that we had b squared at this step right here? So going a step farther to find b, it is okay as long as you still write that as plus or minus that the square root of 3 squared, right? That's okay, but we were done at this step right here. Now I know what a squared is, b squared is. Let's answer this question, right? Don't just leave it all on the paper for someone else to fill in. Write the equation of the ellipse that you were asked to write. So x squared over 4 plus y squared over 3 is equal to 1. All right, so not bad, right? The conic sections are not too bad. Now, in your homework, you're going to get a little bit of exposure to what happens when the ellipse is not centered at the origin, right? Like what if your ellipse was up here? And listen, it's not bad. It really isn't. It's just remember that the center is HK. This is just like when you used to work with your circles of HK when they were not centered. So everything that I've taught you applies. You have all the theory that you need. You'll get a little bit of exposure in the homework to how you adjust when it's not centered at the origin. But just long story short, find the center, the new center, and then that is how you'll get to your result. Last question. So it says, assume that a bridge with a semi-elliptical archway is 40 feet long with a height of 10 feet directly above its center. Okay, so let me see if I can make sense of that. So we have some type of bridge, right? Some type of that's a horrible looking bridge. And so some type of bridge that's semi-elliptical. Let me see if I can draw that. So we got semi-elliptical bridge. And let's say it looks something like this. Oh, God, it's not easy writing with this pen. Stop laughing at me. All right, something like this. By the way, if you see a bridge like that, you probably should not drive on it. Just a FYI. Okay, so if this is your bridge, and it looks like it's 40 feet long, right? So we have 40 feet running from here to here. And it also looks like it's 10 feet in height directly above its center. So 10 feet from there to there. Okay. So what else do they ask us about? So it says, now you're in a truck, right? You're driving, let's say you rented a U-Haul truck or some type of box truck, and it says, will a truck that's 10 feet wide, 9 feet tall, clear the bridge? Right? So let me draw this guy. So let's assume, right? So look, don't be jealous of my ability to draw. Okay, so this is your truck. Now I'm going to go ahead and draw that from the back, right? From the point of view as if we were looking at it from its rear. Okay, so that means we have this truck is 10 feet wide, and it has a height, a clearance of, it says 9 feet. Okay. Now, it asks, will this truck clear the bridge? Like, will it assumes that we're driving in the middle of the lane, such that the center of that ellipse is going to line up directly with the center of this truck. So you're going to drive your truck through that bridge, and the question becomes, well, are you going to clear it, right? Or are you going to run into some problems? So, well, let's agree that right in the middle, if my truck is only 9 feet tall and I have 10 feet of clearance, then I'm not worried about, right? I'm not worried about making contact with the bridge directly above its center, right? Does that make sense? That if I'm going to make contact with the bridge, it's going to come from the corners here, right? If I'm going to make contact, it would be, say, here and here, right? So how do we take an example like this and place it into a problem where we can form an equation and solve it? And let me go ahead and throw a graph in here. And this is one of those skill sets that I wish the high schools and middle schools would spend more time doing, right? I wish that you would spend more time in word problems and the ability to model word problems. Because watch, we're gonna take this question, and when we're done with it, it's gonna fit inside of this rectangular coordinate system. Ready? So let's start with the bridge. So if the bridge, let's assume that it's centered at the origin. Now it's 40 feet long, so that would mean that we're going to go, let's just say this is 20 feet to the right and 20 feet to the left. With me? Right? So 40 feet would be from negative 20 to 20 is 40 feet. And we're going to assume that right here at the center is 10 feet, right? So it's 10 feet, 0, 10, or 10 feet tall. Okay. So far so good. And now let's take our truck and do the same thing. So let's start with the width of our truck. So we have 10 feet in width. So that's going to be 5 feet, let's say 5 feet to the right, 5 feet to the left. Let me go draw that. I'm going to scoot over a little bit more. I don't care if the tick marks line up perfectly. Just this is going to be 5 to the right, 5 to the left. So that's 10 feet, right? So that's the clearance of your truck. All right, now the question is, so here's your truck driving through this bridge. Remember, the question is, are you going to make contact right here? Right? Are you going to tear down this bridge by making contact right there? So let's try to translate that into a real question. So can you agree with me that we can reinterpret that will it clear the bridge as when x equals 5, what is y? Right? So when x equals 5, here's where x equals 5. How tall is, not how tall is the truck. We know the truck is 9 feet tall. But how tall is the ellipse when x equals 5, right? So in other words, what I'm really interested in is I want to know the y value of this point, right? I know that on the ellipse, I know that x is 5, but I really want to know what the y value is, okay? Because look, if the y value is below 9 feet, I'm going to hit this bridge. If the y value is above 9 feet, then I'm going to clear this bridge. Okay, so let's get this into an equation. So the way we drew it, this is definitely a horizontal ellipse. So this is an x squared over a squared plus y squared over b squared, and that's equal to 1. All right, now, what am I going to plug in for a? What am I going to plug in for b? All right, well, in this case, a is remember that a is the distance along the major axis, right? So this is a. So a is equal to 20, and then b would be the distance from along the minor axis from the center to the co-vertice. So in this case, b is going to be equal to 10. All right, so what I'm going to do right now is I'm going to just substitute. I'm going to substitute 20 in for a, and I'm going to substitute 10 in for b, and let me do that over here. So I have x squared over, what do we got, 20 squared, and that is going to be plus y squared over 10 squared, and that's still equal to 1. Let me go ahead and square the 20 and square the 10. So that's x squared over 400 plus y squared over 100 is equal to 1. And now, are you ready for it? So here's what's going to happen. I know that x is equal to 5. What I don't know is what y is equal to. So I'm going to solve this equation for 5. I'm sorry, I'm going to solve this equation for y. And then I'm going to plug 5 in for x. That's how this is going to work. In actuality, I'm going to plug 5 in for x right now. So that leaves me with 5 squared is 25 over 400 plus y squared over 100, and that's equal to 1. And listen, all I got to do is solve this for y, okay? So let's go ahead and do that. I can solve this for y easy if I get rid of these fractions, right? And if I get rid of, I can always just multiply both sides of the equation by the least common denominator. That'll get rid of my fractions. Okay, you don't have to do it this way, but this is the way I'm going to do it. So ready? So you can imagine me distributing a 400 to all three, to both sides of the equation. Well, basically the 400s are going to cancel, leaving you with just 25 here. Now 100 goes into 400 4 times. So that's 4y squared. And of course, 400 times 1 is just 400. Ready? Let's subtract the 25, and then let's divide by 4. So 4y squared is equal to 375. That means y squared is equal to 375 over 4. And now I've ran out of space, so if you don't mind, I'm going to put a pin right here, and I'm going to come over here. So I left off with y squared is equal to 375 over 4. And you guessed it, let's find out what y is. So y is equal to the square root of 375 over 4, which y is, by my calculations, is roughly equal to 9.68 feet. So answer the question. Are you going to clear the bridge, yes or no? So this is 9.68. Well, your truck is 9 feet tall. And as long as you stay centered on the road, right where you're right through the middle of this bridge, the bridge is 9.68 feet tall. So you are going to clear the bridge. If your truck's 9 feet tall and the bridge is 9.6 feet tall, 6.8 feet tall, then you are going to be able to go under the bridge. Okay, that is not a problem. All right. So let's see here. What if I'll ask you a question? I'm not going to answer this question. What if the truck was 12 feet wide? What if everything about this problem was the same, but if it was a 12-foot wide truck instead of 10 feet wide? Right? In other words, you would be going out 6 to the right, 6 to the left. Do you think it would clear? I bet you said no. It would. You got plenty of space, even if it's a 12-foot wide truck. You should run those numbers just for practice and try it. All right, we are going to go ahead and conclude. If I had the time and access to some of my papers at my office, there's another really cool application for an ellipse that deals with kidney stones. So if you ever have time, if there's a thing, it's called a lithotripter, Lithuh, I think, TRIPTER, a lithotripter. And it's a really cool machine that basically breaks up kidney stones, right, using some type of sonic wave. And but if you look at that lithotripter, it's an elliptical machine, and they line. It's a really cool thing that they line up. One of the focal points is where your kidney stone is, and the other focal point is where the shock wave emits from, and they literally just bounce it off the ellipse, use that properties of ellipse, and they're just sending shock waves right to your kidney stone to break it up so that you can pass it. Anyway, we must conclude. I will see you soon.